Alright, let's look at the practice exam 3, problem number 12. Alright, so we want to use the binomial series to expand 2 over quantity 5 plus x to the third power. Alright, let's do that. Alright, so first we have to do a little bit of tweaking here. So we have 2 over 5 plus x cubed. Alright. And first thing I would do is, let's compare with the binomial series. All right, binomial series goes something like this here, binomial series. All right, so it goes something like this, right? So you have a quantity 1 plus x to the kth power, right, is equal to, summation, n goes from 0 to infinity. Then you have a binomial coefficient k, choose n. Then you have x to the n, right? And then where binomial coefficient is defined as, right? This is basically just a general version of number of combinations. So start with k. So k multiply by k minus 1 and multiply by k minus 2. And keep on doing that until it hits k minus n plus 1. This just means that they're going to be k factors multiplied together. Then you're going to divide by n factorial. Alright, so let's try to fit the form here. So we want to have quantity 1 plus x. So we would like to have 1 here. Then we would like to have some power k there. Alright, so let's rewrite it in that form. Alright. First, I'm going to pull out 2 because I would like to have 1 on top. Right? Then there's a 5 instead of 1. So I'm going to pull out 5 from there. So, but you once pull out 5, but it's cubed. So you have to cube, 5 cubed is pulled out. Then what's left is a 1 over. Alright, so 5 is pulled out from 5, it's 1. And the 5 is pulled out from x, so it's going to be x over 5 cubed. All right. Then what we can do is we don't like this fraction form, so I'm going to rewrite it as 2 over 5 cubed. All right. Then I'm going to write it as 1 plus x over 5. Raise it to the, so this guy's sitting on the denominator, so it's a negative power, cubed, so it's a negative 3 power. Alright, then we can see that it fits the form. So this is our k value. Alright, so you can pretend that this is like a x in the binomial series. Alright, so using the binomial series, we're going to get this. Alright, so 2 over 5 cubed. It's just a constant multiple, so put it there. All right, then the binomial series. So this is going to be a summation. All right, n goes from 0 to infinity. All right, then k value is negative 3. So binomial coefficient 3, choose n. All right, then instead of x, we have to have x over 5 raise it to the nth power. Alright, then let's try to simplify as much as we can. So you have 2 over 5 cubed. Alright, we'll take care of that later. Then you have a summation sign here. N goes from 0 to infinity. Alright, so binomial coefficient goes like this. Alright, so we're going to have start from negative 3. Alright, next one is of course negative 4. And next one is negative 5. Alright, then you have n factor of those. And the last one is a -3 minus n plus 1. Right? I'm just following the formula there. Right? And another way to write that would be, so this guy is, let's see, it's the same thing as -n minus 2, right? Which is the same thing as, I'm going to put the negative sign in front, so it's going to be n with a parenthesis, n plus 2. Alright, then you have n factorial, so I'll put n factorial on the bottom. Alright, then you have x to the n, so here is x to the n, I meant n, and on the bottom you have a 5 to the n. Alright, so let's simplify this. Alright, first I'm going to take care of the summation sign. So this is the summation sign. So I'm going to just write that down. Summation. N goes from 0 to infinity. Alright, then you're going to have a big fraction here. So I'm going to just draw that. Alright, and the first thing is, since everyone seems to have a negative sign here, negative sign here, negative sign there, negative sign there, all these factors have negative sign up to the very last one. Alright, so there should be n negative ones multiplied together. So I'm going to take care of that first. -1 to the nth power, because you have n of those. Alright, then we're going to have, let's see, we're going to have a 2, 3 times, 4 times, 5 times, all the way to n plus 2. So I'm going to write, this is going to be 2 times, 3 times, 4 times, 5 times, and all the way to n plus 2. So actually, can I write the n plus 1, and then this is going to be n, and n plus 1, n plus 2, sorry. Alright, so we took care of that, so this is taken care of. Alright, then what else? We have n factorial. Alright, so let's take care of n factorial. So I'm going to write out the n factorial. N factorial is 1 times 2 times 3 times 4 times 5 times all the way to n. Alright, so that's that. And then we take care of the 5 cubed and the 5 to the n combined. So that's going to be 5 to the n plus 3. Alright, then we have here x to the n. Alright, so we can cancel a bunch of things. Let's cancel, right? So you have 2 and 2 cancel out, 3 and 3, 4 and 4, 5 and 5, and all these guys, and the n and n. Alright, so what's left is summation, and it goes from 0 to infinity. Alright, so you have a -1 to the nth power. Alright, then we still have n plus 1 and n plus 2 on top. Then you have 5 to the n plus 3. Then you have x to the nth power. Alright, so that is the power series that we are looking for. Alright, that's it. I hope that this was clear.